Welcome to the Bio Insights, where science comes alive.
Today, we're taking a highly visual, totally microscopic journey straight into the human abdomen. We are going to look right past the glowing blood vessels and transparent tissues to see exactly what happens when the body's natural, life-sustaining fluids suddenly, go rogue. We're breaking down the anatomy of gallstones, how they form, why they form, and the incredible, if sometimes agonizing, biology behind the whole process. I want you to picture something for a second. Imagine a perfectly balanced, shimmering, microscopic fluid system inside your body. It's designed to flow smoothly to help you digest and survive every single day. But then, a tiny chemical imbalance kicks in. What happens when that beautiful golden fluid suddenly crystallizes into hard physical blockages? I mean, it sounds like something straight out of a science fiction movie, right? But this microscopic transformation is happening inside millions of people every single day, often just tucked away right beneath the liver. Section 1. The healthy biliary system, a golden baseline. Okay, so before we can understand how things go wrong, we really need to establish our baseline. What does a healthy gallbladder actually look like? Well, in a healthy body, the liver is continuously churning out bile, and this bile is a brilliant golden green fluid that's absolutely crucial for breaking down and digesting the fats you eat. This fluid flows smoothly down from the liver, travels through these tiny bile ducts, and settles into a small pear-shaped organ, the gallbladder. Inside a healthy gallbladder, microscopic particles just float freely. They don't clump. It's this stunning, perfect harmony of cholesterol molecules, bile salts, and phospholipids, all perfectly balanced to keep that fluid dynamic and moving. Section 2. The most common culprit, cholesterol stones. But what happens when that beautiful chemical balance is disrupted? That brings us to our first and honestly, by far our most frequent type of gallstone. You might think gallstones are all made of calcium or some kind of bone-like material, but the numbers here are wild. An overwhelming 80 to 90% of all gallstones are actually just cholesterol stones. The remaining 10 to 20% are other types, which we'll dive into in a minute. But the vast majority of the time, the culprit causing all that pain is simply built-up cholesterol. The trigger for these common yellow-green stones is purely chemical. As our source material directly explains, when bile contains too much cholesterol and not enough bile salts, cholesterol begins to crystallize. It's entirely an issue of saturation. The bile becomes incredibly thick, literally supersaturated. There is just way too much cholesterol floating around in there and not nearly enough bile salts to keep it dissolved. At a microscopic level, this creates a pretty fascinating visual. The excessive cholesterol molecules floating through the thick bile can no longer stay in liquid form, so they begin to precipitate out. They form these sparkling, geometric crystals that drift through the bile like tiny yellow snowflakes. It's almost like a quiet, beautiful, microscopic winter storm happening right there inside the gallbladder. But as you can guess, those tiny yellow snowflakes don't stay tiny for very long. Let's walk through this creation story step by step. First, these microscopic crystals drift through the fluid, and they eventually collide and merge into larger and larger clusters. Next, the gallbladder's natural mucus acts almost like a net, trapping these clusters in place. Once they're stuck, step 3 kicks in. Layers upon layers of cholesterol accumulate over time, slowly building up. And finally, what started as a microscopic, sparkling crystal grows into a solid, yellow-green, marble-sized rock. Section 3. Dark and brown pigment stones, when bilirubin builds up. Now, while cholesterol is the main offender, it definitely isn't the only one. Let's contrast two completely unique types of stones, because their biological origins are totally different from the cholesterol ones we just covered. First, we have black pigment stones. These guys are hard, they're black, and they stem from an excess of bilirubin, which is a substance released when aging red blood cells break down in your bloodstream. On the flip side, we have brown pigment stones. These are rare, soft, and brown, and they're born from a completely different environment altogether, stagnant bile that's usually caused by a bacterial infection or a physical blockage in the bile ducts. Let's zoom in on those black pigment stones for a second, because the chemistry here is super interesting. In your bloodstream, as aging red blood cells naturally break down, they release this dark bilirubin pigment. When too much of it enters the gallbladder, it hits the concentrated bile. Right there, the bilirubin combines directly with calcium. This specific chemical reaction creates incredibly hard, irregular, black crystalline deposits. And over time, these dark, jagged stones gradually form against the smooth walls of the gallbladder. Now, the formation of brown pigment stones, that is a much more dramatic and honestly kind of gross microscopic scene. This usually happens completely outside the gallbladder itself, in a connected bile duct that's become infected or blocked. Bacteria start multiplying rapidly within the stagnant, totally non-moving bile. Inflammatory cells rush to the scene to fight the infection. And then, the bacterial enzymes actually start changing the chemical composition of the bile, causing calcium and bilirubin to mix with mucus and infectious debris. The end result is the slow development of these sticky, soft brown stones.
Section 4. Anatomy of an attack. The climax.
So it's one thing to have these stones just sitting peacefully in the gallbladder, but it's an entirely different story when they decide to move. And that brings us to the climax of our biological journey, the dreaded gallbladder attack. This is a rapid, intense cascade of system failure. Imagine the powerful muscles of the gallbladder contracting, trying to push fluid out. But instead, a large gallstone moves toward the exit and gets tightly lodged inside the very narrow cystic duct. Step 2. The flow of bile suddenly and completely stops. Step 3. With the exit blocked but the pressure still building up, the gallbladder rapidly swells and the tissue becomes red and incredibly inflamed. Step 4. This massive swelling triggers the surrounding nerves, sending signals of severe radiating agony throughout the abdomen. When this cascade reaches a clinical emergency, the definitive treatment is surgical, specifically a laparoscopic cholecystectomy. Surgeons insert small ports, they actually inflate the abdomen with gas to get clear visibility, and then they carefully clip both the cystic duct and the cystic artery. After that, they remove the diseased organ entirely, putting a stop to the blockages for good.
Section 5. Comparing the 3 stones, the grand summary. All right, let's consolidate everything we've explored into one clear picture. The crucial takeaways for the biliary system's potential pitfalls are right here. First, we have the cholesterol stones. They're yellow-green, they make up a massive 80 to 90% of all cases, and they're primarily caused by an excess of cholesterol supersaturating the bile. Second, the black pigment stones. These are hard and black, far less common, and they're triggered by excess bilirubin from the natural breakdown of aging red blood cells. And finally, the brown pigment stones. These are soft, sticky, pretty rare, and almost entirely the result of an active infection or blockage that makes the bile stagnant. It's honestly incredible to think about the complex, microscopic fluid dynamics happening inside us at this very second. I mean, trillions of molecules of cholesterol, bile salts, and phospholipids are interacting right now, hopefully in perfect, shimmering harmony. But as we've seen today, it only takes a slight shift in saturation, a tiny bit of stagnant fluid, or an excess of a natural pigment to turn that golden fluid into a painful physical roadblock. So I'll leave you with this to ponder. How well is your body balancing its bile today? Thanks so much for joining me on The Explainer, and keep staying curious about the amazing biology happening right inside of you.